with Unit 9, Section 5. It's the last video for circles. We are going to be talking about the different type of segment lengths inside circles. So most of this unit we've been talking about the angles of a circle, angles inside, outside, on circles, at the center of the circle. Now we're actually going to talk about lengths of segments. So all those different chords, tangents, and secants. So instead of looking at angles, looking at the actual lengths of the segments. So we're going to look at 3 different scenarios on what kind of can happen with these segments. So the first scenario is 2 chords happening inside the circle. So this just looks like if you have 2 chords kind of crossing each other inside the circle. So what you can do to solve for the lengths of these chords is you can do that A times B is equal to C times D. A way that I think of this is part times part equals part times part. So a good strategy is to highlight or take a pen or something, go over one chord, and say, okay, this chord is made up of A and B, so then do A times B. And then take the other chord and kind of go over that and say, all right, this one's made up of C and D, C times D. Another way that you can kind of remember this formula, part times part equals part times part, is just think of it as PP. PP equals PP. Down here on this example here, when we take a look at this, again, kind of use our highlighters. If we go over this chord, that's 3 and 6 are the parts for that one, whereas this chord here is made up of 9 and X. So when I go to set that up, I can say 9 times X equals 3 times 6. And then it's just a matter of solving for X. So 3 times 6 is 18. Divide both sides by 9, and we get that X is equal to 2. For this one, it's a little bit more challenging. So the one segment that we have is X plus 4. The other segment that we have is X plus 2 and X plus 1. So in terms of setting this up, PP, part times part, is X times X plus 4. You need to remember that when we have expressions like that, we need to sort of put them in parentheses. We're going to end up distributing. So remember, this distributed multiplication is X times X, X times 4. And then here, think back out to 1, we would do X times X, X times 1, and then 2 times X, 2 times 1. So when we multiply all that out, remember X times X is equal to X squared. So this gives us X squared plus 4X equals X squared plus 1X plus 2X plus 2. So now if we clean this up a little bit, if I subtract X squared from both sides, X squareds actually cancel each other out. I can simplify, the 4X stays there, 1X plus 2X is 3X plus 2. And then from here, subtract the X from both sides, and that gives us X is equal to 2. The problem is not asking us to solve X, it's asking us to find the length of XL, J, A. That's the length of the actual. So the chords are not going to be equal, and that's okay. So here we just substitute a 2 in for anywhere we see X. So 2 plus 2 is 4, 2 plus 1 is 3, so the length of ML is 4 plus 3, which is 7. Here this segment's 2, and then 2 plus 4 is 6, 2 plus 6 is 8. So the lengths of the chords are 7 and 8. So here's an example. You can try this out on your own, kind of see how you do with it. Again, feel free to pause the video and see how you did. So you should get an answer of X is equal to 8. Here's what the work for that looks like in case you are curious. The next kind of scenario is if you have 2 secant lines coming out. So this says if 2 secant lines share the same endpoint outside of a circle. So this is sort of that common endpoint. So notice this is a secant. It's going through the circle at 2 separate points. Then we can say A plus B. So A plus B is this whole secant times A. So A is the outside part, or the exterior part, is equal to C plus D, so the whole thing, times the exterior part. In other words, you can say whole times exterior equals whole times exterior. Another way to remember this is wee wee. So we have PP, we have wee wee. So anytime you're finding the whole, you always have to make sure you add the two pieces together. So for this one, the whole would be 9 plus 11. The other whole would be 10 plus x. So here's what that setup looks like. So 9 plus 11 times the exterior part. So the exterior part on that segment is 9 equals whole 10 plus x, or x plus 10, times the exterior part, 10. And now again, it's just a matter of kind of cleaning this up, adding, distributing when we need to. So 9 plus 11 is 20 times 9. 10 plus x, we can't do much with that, so we'll distribute the 10. 10 times 10 is 100. 10 times x is 10x. From here, 20 times 9 is 180. The 100 plus 10x stays the same. So then subtract 100, we get 80. 80 equals 10x, divide both sides by 10, and we get x is equal to 8. So again, this is just another example of wee wee, so whole times exterior equals whole times exterior. So the whole thing here would be x plus 3 times the exterior bit, which is 3, equals the whole thing, which is 5 plus 4, times the exterior part, which is 4. So then this is sort of the work for that. So remember, distribute the 3 here. If you want, you can distribute the 4, but I think you're making more work for yourself. It's easier to just add these together. 5 plus 4 is 9, and then 4 times 9 is 36. Subtract 9, we get 3x equals 27. Divide by 3, we get x equals 9. Alright, and then the last scenario that we will look at is a tangent and a secant. So remember, tangent only touches the line at 1 point. Secant goes through the circle sort of at 2 points. So the mathematical way of looking at this is a squared is equal to b plus c times b. So it still is kind of like wee wee. So you're still doing whole times exterior, but in this case the tangent is both the whole thing and it's the exterior. Another way to think of it is whole times exterior equals tangent times tangent. So you can kind of think of that as wet. So we have PP, wee wee, wet. So whole times exterior equals tangent times tangent. So here, 24 is my tangent line, and then this is my secant. So we're going to do whole times exterior equals tangent times tangent. So this is what that setup looks like. Remember, whole, we add the pieces together. So from here we would distribute the 16. 24 times 24 is 576. And then just solve for x. So you end up getting x is 20 here. For this one, the tangent is x. So we're going to do whole times exterior. So that's 14 plus 6 is equal to times the exterior, which is 6, equals tangent times tangent, which is x squared. So remember, x times x is x squared. 14 plus 6 is 20. 6 times 20 is 120. 120 equals x squared. So now from here, remember, we have to square root both sides. So if you're giving a decimal answer, you should get about 10.95. If you wanted it in radical form, you should get 2 square root 30. So just to quickly summarize, if you have two segments intersecting inside the circle, that's going to be part times part equals part times part. If you have two segments outside the circle, it's basically the whole times the outside equals whole times the outside. Again, another way you can remember this is PP, wee wee, wet. Alrighty, that got weird at the end there. Okay, so thank you for watching. That's the last video on circles. Make sure you look out for the top 5 and under 5 video. Thank you for watching. I know it, and hey, now you know it too.